Hey guys, so we're gonna go ahead and do a free response question. This is after the AP exam. And let's go ahead and attack this one. So we have this graph, and sorry, I screenshot that off. This is the graph of F. Sorry. Okay, so you should have about 25 minutes to go ahead and answer these questions, but 5 minutes will be done to submit your work. So in reality, you have 20 minutes. And this was on the link that I provided you. So we're just going to go ahead and talk about the solutions. Okay. So they give us some information right here, the function f. So pretty much what I just said, the function f has the following domain, -8 all the way to 12. So it is a continuous function, and it's made out of line segments. And they tell us that the function g is defined by this right here. So what I want you to already start thinking is, you need to start thinking, okay, I'm most likely gonna have to use the area under these curves right here. And I will be needing to do something with this g function, but it has an integral. So automatically what I would want to do is write out what I know, g of x is equal to this integral, which is a little bit common, right? And then f t dt. So that means g prime of x is just going to be our function f of x, and g double prime of x is going to be f prime of x. So pretty much the first derivative of g is going to tell me the original function, and the second derivative of g is going to tell me its concavity, right? The rate of change. I'm sorry, the rate of change of f. So the concavity of g with the rate of change of f. So a little bit tricky, but not that bad. And from here, it looks like we have everything we need to go ahead and find some solutions. Okay. All right. So the first question, it's asking us, find the x-coordinate of each critical point. So keyword there of g. So not f, but g. So let's define critical points. Remember, a critical point is when we either have an undefined or the derivative, right? The derivative of whatever function we're working with, the derivative of this function is equal to 0 or undefined. So let's go ahead and check that out. If I look at g prime, right? G prime of x is gonna be the following. Sorry about that. What was I gonna say? So if this is g, right? This is g. So g prime of x is going to be the derivative of this right here, which is the derivative of that integral. So according to this fundamental theorem of calculus, it's just this right here, the f prime. So when f of x equals to 0. So it looks like we have right here, which is -2, right here, which is 1, 2, 3. And right here, which is 6, and right here, which is 12. Okay. So it's asking us, what were those solutions? Oh, I'm sorry. This 12 right here is not included into our interval because it's an open interval. So our only critical points on G. So critical points on G are the following: when x equals what we just said, -2, 3, and 6. 12, it is also included into that it is, but since we are working with the open interval, because this is just open, I did not include that 12. Okay. All right, the next part says determine any x values on the graph of G. So from what we know, that has a minimum. So luckily for us guys, this is a continuation from this part, since it's asking for minimums. So minimums and maximums only occur on these critical points, right? So in order for us to have a minimum, that means our function has to do decrease and then increase, meaning it has to go from negative to positive, right? So let's go ahead and check. And this can also be, if you're using the fun chart, this can also help you out in trying to find that idea. So we're only going to check these parts right here. Let me change the marker. What's happening here at -2, what's happening here at 3, and what's happening here. We want something to be decreasing and then increasing, aka this is going to be going from negative to positive. So let's check at -2. This is positive to negative. So this is most likely telling me that this right here is positive to negative. That's going to be a max. This one goes to negative, right? Because they're below. So that's going to be a saddle point. And this one right here goes from negative to positive. So according to this, we have a relative minimum at x equals 6. And this goes because we're looking at the rate of change, right? Which in this case is our original function f of x. And it went from negative to positive. So we can write this out as, we can say g has a relative min at x equals 6 because we can see that f of x changed from negative to positive at x equals 6. All right, let's go ahead and try the next one. Okay, let's go ahead and do this one. So if at any time you can go ahead and pause the video so you can try it first, and then I'll explain the solution. Okay. See right here. Okay. So for this one, we want to find g prime, and g double prime. So pretty much what we had written down the first time. We know that g of x, right? G of x is given to us as the integral from -2 to x on the f of t dt. That means g prime of x is going to be f of x, right? And g double prime of x is going to be f prime of x. We had done already some examples like this, so these shouldn't be that bad. Okay, they're telling us at -5. So for the first one, we want to find the integral from -2 to -5, because it's the value we're looking at, for f of t dt. So it's not that bad. It's pretty much telling us what is the area between these intervals. The only thing I want you to see is that this right here, this lower limit of integration, has to be the smallest number, and this has to be the larger number, right? So is it true? Is this true? Well, actually, no. -5 is way smaller than -2. So what you're going to go ahead and do is first flip these. And the only way you can do that, because of a property, is if you make it negative. Now we can find the area. So you're going to find the area from -5. So this is -2. And -5 is right here, right? So you want to find this area right here. Not that bad. Looks like a little triangle. This is 3. This is 1. So 3/2. Sorry, don't forget the little notation. We said this was 3/2. Don't forget this was negative, so this has to be negative. Even though this was positive, this was 3/2, but it's telling us that it is negative. The next thing we want to go ahead and do is find g prime. Sorry, I don't know where to write. G prime of -5, which is in this case f of -5, which is not that bad. It's a height. So at -5, which is this right here, what is that height right here? So it looks like it's 1 positive. because that is the y value. This coordinate right here is -5 and 1. Easy peasy. Next one, g double prime of -5 is the same thing as asking f prime of -5. So that's telling you the rate of change at this point right here. So what is this rate of change? So pretty much the trick here is to kind of rise over run. So what is the slope? But it's not that bad. We can see that this is going down 1 and then running 3. So rise -1 and run 3. So 1/3 looks like it's that. If at any time you have questions, you just email me or text me and I'll help you out. The next one. Find intervals where it is both decreasing and concave up. So believe it or not, you could actually use the fun chart for this. So whenever you're actually thinking about decreasing, let me get a different marker. What is happening? Where is my pen? I lost it, guys. Here it is. Sure. So pretty much when G is decreasing, automatically, what do you think of when G is decreasing? Well, let's go ahead and see that. Sorry. When we go ahead and, I lost myself. You need to find out what's happening to this right here. So when something is decreasing, that means its derivative, right? Its derivative is negative. And it's concave up, that means its second derivative is increasing. The rate of change is increasing. Or should I be writing it in F? So let's go ahead and look. When is the function negative and increasing? So we can see that it is negative all of this part right here. So let me go ahead and erase some stuff. Purple's fine. So it is negative all of this right here. So that means it's decreasing. So from this point right here, from -2 all the way to, oops, why am I forgetting this? 5, 6, 7. 7. So from -2 to 7, it is negative or possibly decreasing. I'm sorry, it is decreasing, so it is negative because my F is negative. Okay, so then next thing is G double prime. That means the slope has to be increasing. So the slope, go ahead and get a different color. So when is this slope right here? We're talking about the slope. When is it increasing? Well, it's only increasing right here and right here. So this part right here and this part right here should be my solutions. So it should be on the open interval, keyword right here, 0 to 3. This is this interval right here, 0 to 3. And this interval right here, union, 5. Is it 5? 5 all the way to 7, sorry. 7? 6, sorry about that. What's wrong right here? This is 6. And this is because, so we can say G is decreasing and concave up on this open interval because G prime is negative and G double prime is increasing. Again, you can email me or text me if you have questions, but it does get a bit confusing with the F's and the G's. Let's find the next one. G12. So not that bad. G12. Just telling us from here to here. So it's asking you what is the area from -2, so from here all the way over here. Just keep in mind that you're gonna get some numbers here. Keep in mind that if they are below, they are negatives. Negative, negative, right? Plus whatever this is, which will be positive. So you're gonna get all that area added together. And keep in mind that you do not need to simplify according to what they stated. So you can just write it out, you'll be golden. Oh, it shouldn't be that bad. Let's go ahead and do the next one. So this one right here, you have to find out the absolute max. So very, very different from what we did over here when we saw the minimums. We saw this on question B. Very, very different because this is relative. For, what am I doing? For this one right here, the absolute min, you have to use EVT. What that means you have to check your endpoints because those are possibilities of the max height. I'm sorry, yeah, max height. So you're gonna make a table. Whoops. And you're for sure you're gonna have the endpoints -8 and 12. And what also is gonna go here, can't forget, is the other critical points that we had found earlier. So go ahead and put those in there. So all of the values that you saw earlier where this had either undefined or a 0. So these points I believe were -2. 1, 2, 3, 3 and 6. So those go on there as well. 2, 3, and 6. Okay. Once you do that, guys, you're gonna go ahead and put them into the function g. And we all saw that the function g is actually the integral from -2 to x to f of t dt. So pretty much what you're gonna do is substitute and evaluate. So I won't do them all, but I'll just set up the first one, -8. So it's gonna be -2 to 8 f of t. So pretty much the area from -2 all the way to 8. So all of this, whichever one of these has the maximum value, the maximum number as a solution, is gonna be your maximum height. So let me go ahead and get you that answer. And I believe it was at 12. At 12. So if you were to go from -2 to 12, for this right here, you get 3/2, and that is the solution. I do want to talk about this one right here. When you take the integral, let's say this one, -2 f of t dt, and then you pick the value that they gave you. In this case, it's -2, so that's the upper bound. When you integrate from that limit to that limit, you didn't move at all. So that was 0. So I know a lot of students would get that one wrong. But in this case, if you try them all, you get that the maximum, the absolute max occurs when x equals 12. Okay, we're almost done, guys. Let's go ahead and try the next one. So this one says, let's find h of x when it is given to us here. So find h prime. So this right here is going to talk about chain rule. So remember, if you have a function, let's say, I don't know, f, and then we have a little g in here. And someone told you, hey, find me the derivative. Well, you find the derivative of the outside, right? The inside stays the same, and then you do the derivative of the inside, which is my g prime of x. So that's pretty much what they're doing. That's not bad stuff. So they want you to find the derivative of h, given that h is this function right here. So what I like to do is I like to rewrite these. And they gave us square root of f of x. So in my eyes, that is f of x to the 1/2. So you can probably see that the chain rule, the 1/2 is the outside function, the f of x is the the inner function. So if I derive this, I get the 1/2 in the front. My f of x stays the same, and I subtract 1 from the derivative. And then I derive from the inside, this right here. So the derivative of that is just f prime of x. Okay, so this is my derivative. This is my derivative h of x. They want me to find h prime of x when it is x is 10. So 1/2 f, every time I see x, I put a 10, negative 1/2 times f prime of 10. So not that bad, guys. Let's go ahead and solve this. So this is 1/2. I got the square root of f of 10. Very nasty. And the slope at 10. So let's go ahead and solve this. What is my y value when x is equal to 10? Let's figure that out. It looks like it is a 2, right? Because this is the point 10 and 2. So it's 1/2 square root 2 times whatever the derivative is right here. So what is this derivative? What is this line right here? It appears that the tangent line to this is going to be rise 1, negative 1, right? And then run 1, so times the negative 1 over 1. So all of this is negative 1 over 2 square root 2 as my h prime of 10. Okay. All right, the next one says to find a particular solution given this differential equation, and it appears I'm going to lose a little bit of room, but let's give it a try. If not, I'll just see what I can do. So I got dy dx is equal to negative xy plus 1 squared over 12. So the first thing I want you to do is pretty much just move all the x's to one side, all the y's to one side. So this doesn't look that bad. It is actually, this is going to be y plus 1, negative 2 dy, and this is negative x over 12 dx. From there, what you need to do to go ahead and get rid of this integral is, I'm sorry, to get rid of this dy dx, you're going to have to integrate this. So let's go ahead and see that. You pretty much have to find that integral. So I added a 1 and then I divided by that new exponent. So that's right here. And you can always check your work by deriving. If I derive this, this negative goes to the front, I subtract 1 and so forth. That's what I got there. This x, if I integrate x, well, if I integrate this right here, and I guess it's a little messy. If I integrate, I just like putting that on the outside, that becomes add 1, divide by that, so I got this right here. Two, yeah. Let me double check my work. Yes, so far so good. Don't forget that we integrated, so we add that plus c. Okay, the next step is we need to solve for what c is given this initial condition, 12 and 0. So all you need to do is substitute to find out what this is. So let me go ahead and make this a little bit prettier. Y plus 1, negative 1 equals negative x squared over 24 plus c. So pretty much that's, you have to go ahead and substitute this 0.12, 0, and we can go ahead and find that out. And I got that it gave me a 5. Yeah, 5. Yeah, A5. Yeah, so C, once you substitute 12 and 0 into all the 0 for this and 12 for the x's, I got that C equals 5. So in reality, it was y plus 1, negative 1 equals negative x squared over 24 plus 5. So that's what I got for that. That is the particular solution of this one. A quick note is that something good to do is to actually solve for y. So let me see if I can do that. That's gonna be plus 1 to negative 1 x squared over 24 minus 5. Okay. It's just gonna get a little tricky. So this is to a negative 1. So ideally this y plus 1 is in the denominator. So if I swap everything, it's gonna be y plus 1. It's now in the numerator. That means everything on the other side changed, it flipped. So 24 over x squared minus 1 over 5. Let me check with that. Check my say something I shouldn't. Square. That's good. That's how it should be. This one here. Other than that, guys, it should be. Other than that, you can email me or text me for help, and I'll gladly reach you as fast as I can. Other than that, it should be good.